Good evening, friends. Now let us look at one more problem. So far we have been discussing only problems related to springs, because this was one area which many of the students felt uncomfortable, and they wrote me regarding this some mails that these problems need to be worked out. So I'm just working out these kinds of problems. Okay, so far we had looked at, okay, what kind of equation should we use when we use springs? Should it be an energy equation? Under what condition can we use? And we have learned that you can use the force equations, okay, only if and only if both the sides are constant or both the sides are variable. But if one of the sides is a constant, other one is a variable, then you should not use force equation. As for example, in this case, this is a crucial mistake which most of them do it. They equate the mg to kx, okay, and thereby they get this answer. Now, if you equate it here, you observe that this mg is a constant force, kx is a variable force, because k force depends upon the displacement, and as the displacement increases, the force also changes, and hence this is incorrect to equate these two, and as a result of it, this should not be done. So whenever, okay, there's a difference, like the nature of the force, one side you have constant force, the other side you have a variable force. Mathematically you may equate, but logically, okay, it will be incorrect. So as a result of it, you should never do this. Okay, so this is what we have seen in the previous lectures. And now let us look at one more example. And here is a quite a different example which is related to your free body diagrams. Okay, so towards it. Now, two masses. Now, will the acceleration of masses in the system, spring system, be the same? This is what is the question here. Okay, so towards it, two masses of 10 kg and 20 kg. You have 10 kg, 20 kg are connected by a master spring. A force of 200 Newton acts on the 20 kg mass. Okay, this is a force acting here. And then at the instant when the 10 kg mass has an acceleration of 12 meter per second square, which means this object is moving at 10 meter per second square. 10 meter per second square. Towards right, the acceleration of 20 kg mass will be. Now, when you read this statement, now somewhere you relate this, the students relate it to something like this. There's a force acting here. There are two blocks of different masses and is connected by a string. Okay, and then if this has an acceleration A, then what should be this acceleration, right? So most of the time we have seen that this acceleration will also be the same. Now, why should it be the same? Because it's a string. It's a rigid string. The distance between these two never changes, right? Distance between these two never changes. Now here what is, and as a result of this, okay, most of the students have written the answer that 20 kg mass should also have 12 meter per second square. That's one kind of response we have got. And the second kind of response which the students suggested is, maybe they took it in a different way. They said that the force that is acting on this 20 kg mass is 200 Newton. And the force that acts on this one, because it is moving at 10 meter per second square, 10 into 10 should be 100. So therefore, it should be 100 plus, it's moving at what acceleration here? 12 meters, sorry. Go to this 10 here. Okay, 12 meter per second square. 10 into 12 is 120. So as a result of it, you have 200 plus 120, which is 320 Newton. Total force should be 320. Now total mass here, mass of the spring is 0. So total mass is 30. So force by mass gives you acceleration. Thus the answer should have been 32 by 3. Okay, this is the second answer. Now remember, both the answers are incorrect. Now the misconception here is that you have not understood properly about the springs. So what does the spring say? Spring says that you apply a force, there is a deformation being observed in the force, in the spring. Okay. As a result of it, we need to solve it. Now, first of all, if I arrive at this answer, that means, okay, definitely I have not understood what a spring is. If I arrive at this answer, I have not understood what you mean by FBDs. Okay. Now let us look at, okay, how to solve this problem. So I have addressed both the misconceptions here. Okay. A spring is something who, when you connect it between two objects, the distance between the two objects will vary, and hence acceleration of the one object will not be equal to the acceleration of the second object. This is the first misconception. This is a concept that you need to know. Okay, when you connect two objects with a spring, it is not equal to that of a string here. Okay, then the second concept that you need to know here is that when you apply a force over here, when you apply an acceleration, when you say this moving with an acceleration, yeah, this refers only to this acceleration alone. Okay, it does not refer to this acceleration, and you should not multiply this acceleration by mass to give rise to the force acting. Okay, which should be incorrect. Okay, now let us see how you solve this problem. How to solve this problem. Now towards it, let us draw the FBD. Let us take the first object. First object, you take it like this. This is your 20 kg object, 20 kg, no friction. So 200 Newton is acting here. 200 Newton is acting here. When you are pulling it, so definitely there will be a pulling force here also. There will be a pulling force. Let me call this as tension force. Why does this happen? Because there's a string connected here, spring connected here. So definitely there's a tension acting over here. Okay. So towards it, let me write the free body diagram here. Let us say this is moving with an acceleration here, which I do not know, which I need to find out. Okay. So definitely from these examples, this is incorrect. This is incorrect. Now you have only two options, right? So we don't have a choice like phone on friend, like our KBC. Okay. So let us solve this, right? So therefore, now we have, with respect to the first object, I have 200 minus t is equal to 28. This is my first equation. Now let us look at the second equation, second object. Now the second object, it is already moving with an acceleration a equal to 12. This value of a is already given to you. Happy? And then you have the same tension which has been present over here. The same tension is given over here. Okay, and then what is the mass? 10 kg. 10 kg. There is nothing else which is pulling backwards. Okay, so therefore it is only 10 kg over here. Now I can write from here as tension is equal to 10 times. What's the value of A? 12. 12. So this should now be equal to how much? 120. 120 unit Newton. Okay, so now I got the value of tension. Let us substitute it over here. When I do that, what do I get? I get 200 minus 120 is equal to 28, right? Or this will be 80 should be equal to 28, or A should be equal to 4 meter per second square. So which is the right option? C is the right option. Okay, I hope you have understood this problem. So problems of such kinds, you need to do it very carefully. It seems that, okay, it is very similar. Okay, so but there's a slight variation in the concept. Okay, that's what you need to identify. And if you like this video very much, then you can share and subscribe to my channel for getting further updates. Thank you, friends, for watching this until the end.